Hello and welcome to our demonstration of supply network model. In this video, I will be guiding you through various insights generated by our model, and we will also be looking into any of the disruption of arising based on different scenarios. So as we can see here in this our supply network, we are having two suppliers which are supplying three raw materials A, B and C. Then these raw material goes through the manufacturing plant and gets converted into a finished product, which we then finally supply to our customers. There is a demand of around 4800 units per year, or we can say 400 units per month. We are assuming here that we have an inventory turn of 24 units. This means at starting of each year we are having as much as raw material in our inventory as it is required to produce 200 units of finished product at the end of each year. We are assuming that we are having a supply lead time of 12 days and production lead time of 15 days. We have also taken into account that we need 1 unit of raw material A, 1 unit of raw material B and 2 units of raw material C to produce 1 unit of the finished product. Now, based on all of these assumptions, we have developed an any logic simulation model. Now, let us go through the model that we have developed. So here we can see this is the model that we have developed. This is the supply of raw material. Then we have the manufacturing process going on, and then finally we are supplying the finished product. We're also having a supply demand block here, which shows that when demand is coming, it is triggering the supply of raw material. Then manufacturing process is carried out, and finally we are supplying the finished product to our end user. Now let us run this model and test it depending upon different scenarios. Firstly, we are running this model for the first scenario, which is all supply within agreed timelines. That means there is no other delay other than the lead time, that is of 12 days for both the suppliers. So we have set the supply delays, that is 12 for both the suppliers. Now let us run this model. So as we can see, our model is running. Below we can see there are two graphs. The first graph shows the average utilization of workstation and the second graph shows the recurring monthly production. So at the end of each month we can see that what is the total number of products which we have manufactured to which is ready to be supplied at the end of the month. So here we can see at the end of first month we are able to manufacture around 250 units of the finished product, which is lesser than the requirement, that is of 400 units. Then so in the subsequent months we are able to fulfill all the demands, that is around of 4 400 units, and this will go go on for the whole year. In total there is a demand of around 4800 units in the year, and we are able to supply around 4600 units. So this was our first scenario. Now let us run this model for the second scenario. Now we are running this model for the second scenario, which states that the supply will stop for 10 days. So it means there is a total delay of 22 days, 10 plus 12 days of lead time for supplier 1, and it will be same for the supplier 2, that is 12 days of lead time. Now let us run this model for the second scenario. As we can see, our model is running, the processes are carried forward. Now let us see the second graph. So here we can see this model is running for the whole year, and here at the end of the first month we are able to supply around 200 units of finished product. Then there is a disruption of around we can say from the 38th day to the 37th day, which means there is a 7-day disruption happening here. After that, in the second month we can see there is a total supply of around 300 units at the end of the month, and after that from the third month we are able to fulfill all the demands, that is of 400 units till the end of the year. So in total there was a demand of around 4800 units in a year, and we are able to fulfill 4400 units demand approximately in the second scenario. Now let us run this model for the third scenario and compare these cases. So after running the model for the third scenario, similarly, we are getting this graph. In the third scenario, we have supplier 1 stop for 30 days. So here we can see at the end of first month, we are able to supply 200 units of finished product out of the 400 unit demand. And in the end of the second month, we are able to supply only 60 units of the finished product out of 400 units demand. There's a supply disruption of around 27 days happening here. And after that, from the third month to the end of the year we are able to fulfill all the demands, that is of around 400 units every month. So this was our third scenario. Similarly, following these rules, we can run this model for any number of scenarios. Also, we can make develop and make model for different number of suppliers or different number of raw materials, and along with that we can also develop a 3D model, which will be an advanced version of this model also, which will be based on the same logic as we have developed here. So that's all for now. Thank you.